Okay. Eduards, I'll give it over to you. So a second keynote for you.
Thank you.
Enjoy, and we're looking forward to your talk.
Yay! So, my friends, let's make some noise at first, right? Woohoo! Yay! Yay! It doesn't really work well because you feel tired. You know, I feel that you are tired. Can we give one more try? Make some noise! Yay! That's much better now. So, and thanks to Sven, actually, I'm kind of giving a keynote now, right? So, life doesn't really suck all the time, right? Okay, my friends, so what's the plan for today? I'm going to share a few stories with you about continuous delivery. And these are not going to be like a sweet stories about how life is good in the companies. These are like a true battle stories of continuous delivery adoption. And basically, you will learn how companies failed. Some of them recovered, some of them no. Sounds like a plan? Yeah. Yay, perfect. So, the first story. Lack of organizational alignment. Basically, this is also called shadow continuous delivery. Have you heard the term shadow IT? Shadow IT, which is quite popular. It actually means that shadow IT happens when people are doing something in the company without the agreement from the rest of the organization, like silent. They do sound like a production deployment, so no one knows, right? So this happened in Germany about 2 years ago in a fintech startup. And here's the story. So once team decided to implement continuous delivery. So they had 2-week sprints, which sucks, right? 2-week sprints, oh, boring, right? No one is doing sprints anymore. So we have to deliver every time, after every change. So there was a smart team lead who said, how should we start with continuous delivery? And he said, let's start deploying once a day. Everyone, yay! Developers are happy, yeah, that's a true engineering, right? That's how modern companies do. So together with the team, developers, they went to ops guys. So ops guys were separate. That was a huge organization, and they were like fully enthusiastic. They went to talk to ops guys, standing like this. Hey, you know, ops guys, we want to start deploying once a day. And what ops guys said? They said, fuck off. They said, fuck off. It will never happen. What you're talking about, you know? And what developers said? Fuck off, and they left. And okay, you don't get us, so you are not innovative enough, you don't get continuous delivery, like sit in your room and do operations. In a dark room, developers, they have implemented something that's called deployment pipeline nowadays, right? And they started deploying once a day, after every feature is ready. It goes to production, yada, yada. But according to change management practices in that company, the rule was to prepare a list of changes before every sprint and hand it over to ops guys, right? Very easy to trick. Developers, even though they were deploying once a day, at the end of the sprint, they prepared a list of changes. And it looked like all these changes go to production after 2 weeks, like at the end of the sprint. Great trick, right? That's how you can trick the system, okay? Yay, great. Everything works, developers are deploying to production every day, ops guys think that they're deploying at the end of the sprint, everyone is happy. And suddenly, production goes down. Boom. Ops guys, because they were running production, they receive a call from a management, and there's a silence. And ops guys have to explain something, right? Something's wrong, right? Production is down. Ops guys are calling developers. Hey guys, did you change anything? No? No. Okay, let's look in the list. Nothing changed. Production like the same, but for some reason it's failing. So, and consequences are quite shitty, I would say, because it took them about 6 hours to recover production, and the major reason was that developers are not willing to admit that they're deploying once a day. They were being afraid of punishment. Okay? So consequences. SLA was missed from with this particular integration partner, and they lost about like 20K customers in this day, which is quite bad for a startup, right? 20K customers here and there, like who cares, right? So they lost trust between management and IT, obviously, because they hired the best, but the best led to some crappy situation. Obviously, they lost trust between dev and ops. Team lead was fired next day. That's what you usually do with the poisonous people who think that they're smarter than the rest of the organization. That's what they did. And surprisingly, in a few months, company went bankrupt. Bam, they completely shut down the business because that particular integration partner was very important for them. They had the luxury to work with this partner, and they actually failed, and the business went down, collapsed, like a butterfly effect, like a small miscommunication can lead to a company collapse. Nice, yeah? Yay. And by the way, integration partner issued a lawsuit as well, so they're still somewhere in the middle of like a negotiation how to solve this problem. Okay? So, what can we learn from this story? First of all, we have to understand that continuous delivery is not about tools until we pick shitty ones, right? It's not about tools because it's about people. And in every complex human system, what's important is alignment. So before doing something in the company, you have to make sure that everyone rides the same bus. Everyone works in the same like a wavelength, right? And everyone understands where the organization is going. What's important, we have to see reason behind every denial. Basically, if someone says, no, it's not possible, just shut up and listen. There should be a reason for that. Do you like it or not? It doesn't really matter, but you should be good listener. Just empathize, right? Listen what's wrong. And ops guys, they usually have a reason for saying no, right? And I believe that it's very good practice to, if you join a company, spend like a month working as an ops guy, if there's a notion of ops guys in your team. Like spend a month on that side. A lot of questions will just disappear magically. You'll be much more better developer, right, than software development professional. You can do pair ops as you do pair programming, right? Why we're not doing pair ops? Or maybe some of you do. So pair programming is sort of like a common sense now. Why pair ops is not? I don't know. And of course, it was already mentioned, like you build it, you run it, which is a game changer. I believe that you build it, you run it approach changed the dynamics of the game completely. People start behave differently. Okay? We have to learn how to compromise as IT professionals, right? Between one-day deployment and once in a 2-week deployment, there are 50 shades of gray. 50 shades of gray in between. You can start with one deployment every week, not every day. Maybe it will be much more easier to, it will make your life easier and you'll be able to convince ops guys and the rest of the organization easily. And there's one more thing, apply beer-driven diplomacy. This is a major. So sometimes there are people in the company who do not agree with you, just in the sake of disagreement. They argue because they don't like you or they don't like life or I don't know, whatever. But they have reasons for that, right? At least they think so. So what you do? You never argue back. You say, okay, man, let's have a beer. Silently, you leave the company, you go to the bar and shut up and listen. The lifestyle, na. You listen. You never argue back. Say, okay, yeah, it's reasonable. Next day you return to the company and you see absolutely different person. Absolutely different person. That's the trick. So if you have this situation, beer-driven diplomacy at your help. It even has a name, beer-driven diplomacy, right? It works. What's important? I believe that QA professionals are now part of every cross-functional team nowadays, right? But for some reason, operations are usually still in the separate department or in a separate team. So why can't we just move these guys to the cross-functional team and work as a single team instead of building the well-polished communication process between dev and ops? Why not to just forget about the process at all and merge them together, right? So they work as a single team. This is perfect. And there are major complaints. Oh, we can't because we have many teams and we have to make sure that our infrastructure is unified, we comply to security guidelines. Yes, of course. Yes. And it's not a rocket science because Spotify solved this problem I don't know, 5 years ago or even more, by introducing chapters and guilds, right? So make sure that your ops people, which are part of cross-functional teams, they meet on a regular basis, they discuss the direction. Is it really hard? Come on. It's not. Let's move forward. Relying on a tiger team. So, it happened about 3 years ago in Latvia, the country where I'm from, in a fintech enterprise. So, company, not a team, but the company, decided that the company needs continuous delivery. Continuous delivery, trendy stuff, right? Let's have a continuous delivery, right? So, what company did? Company decided to pick the best people from different teams. You will be part of this continuous delivery project. You will not. You will be part of this continuous delivery project. What about me? You will not. So sprint, do business stuff and do features, and you will be the rock star, right? So they have. So the company created a rock star team, like a tiger team comprising of the best talent in the company. So in a dark room, the tiger team implemented deployment pipeline with the fanciest tools available on the market, like a Docker, I don't know, Docker, whatever, like a Kubernetes, everything was there. So it was like an R&D team for half a year. So there was playing with tech without even talking to the teams, without involving anyone else. So they build this pipeline, and sort of, what does it mean like a pipeline is built? You have to probably battle test it on production, right? So the next step was for them was going to the slaves, right? Slaves, probably slave team or losers, going to losers and convincing them to make a deployment. So tigers took their pipeline, went to losers. Hey guys, I know that you're burning out with this sprint and these features and this firefighting, but now it's time to make a deployment right. Right? Go ahead and do a deployment for the pipeline that we build. Losers are looking at them. Why should we care? It's not our problem at all. What did you build? There's a Docker, there's a Kubernetes, there's everything inside. It's the best stack ever. Why bother? Just we're firefighting with sprints. So it's never going to happen. Tigers, angry, left. They capitulated and returned back with the management. Hey guys, wouldn't it be cool if you deployed through a deployment pipeline in the next 2 weeks? And since overtimes were paid, so slaves agreed to say, okay, fine, we'll do it at night. So at night, they tried to go to production through this pipeline. First attempt, second attempt, like it's total missed feed, basically. So tigers thought that they are building something that matters, but at the end of the day, it was just sort of a waste of time. It's like but anyway, after like 10 attempts within the bug fixes in the pipeline, they went live. Yay! Pipeline is green for the first time. Yay! After half a year of work, right? Perfect. Everyone is happy. Tigers are happy. Engineered. Losers are happy. Okay, now we can leave, right? So tigers left, and the drama is that next deployment was made again in the old fashion. You know why? Because no one actually needed this pipeline, because deployments were quite okay without that. That's the first reason. And the second reason is that just in spite of tigers. Just in spite of tigers, right? That's built by them for them, not for us. So we, they. So, right? So what can we learn from this? First of all, again, according to the best practices of change management, you have to involve those who are affected by the change in the design of a change. How can you, so if someone doesn't really want something, how can you convince these people to use something? God forbid you're building something for them, that you waste your time, then you bring it, and they say, fuck, we don't need this. So this is a waste of time, right? Secondly, like overutilized slaves or losers, they can't do continuous delivery, right? In order to innovate and improve, you need time. And some companies try to solve this problem by bringing more human power, like hiring contractors and thousands of contractors to solve all their problems. Come on, fine, fantastic. But I would rather actually prefer basically given a time to this team, and so they can innovate. Maybe they will come up with continuous delivery. Maybe they will not, right? But continuous delivery is like maybe it's the best solution for the problem of the reliable delivery and the fast one. Maybe it will go out of date in 5 years. What will you do when your contractors will leave? So you better make sure that your team can continuously improve. And then they come up with great ideas how to improve their delivery, right? So it's not a journey. It is actually a marathon. You can't do continuous delivery. You can pursue continuous delivery, right? And there's always a way to improve. So it's a journey. You can, hey, now we're doing continuous delivery. That's bullshit, right? You can't. There's a long road ahead. And in order to pursue this road, you need time, not external help. Okay? Makes sense. Perfect. Newton's law of software development. So in software development, in the world, in IT, whatever, there are laws or like guidelines you have to stick to. And they are just there, and you have to obey, right? It doesn't, so it just works this way. And today there were one fundamental law mentioned, like Conway's law, right? Everyone sort of knows what Conway's law is nowadays. Conway's law, yeah, everyone knows, right? Okay. So Conway's law, basically the simplest possible definition. You better make sure that your architecture and the team structure are in sync, right? They are reflective, right? So, okay, and that's it, sort of, simple. Here's the example. There was a team in Latvia that was working on the fantastic and huge monolithic code base. And since the company owners thought that they're ridiculously slow, this Latvian team, right? They're going for a coffee and going for a lunch, right? So they're slow. The company decided to hire a team in America. Actually in California, which meant for these two teams that there's a natural wall between them, because they can't really communicate. There's a wall, there's no time overlap at all. They can't really talk to each other. Sometimes they can at evening, like when the time overlaps, but that's a challenge. And they hired the agile coach to improve the delivery. And this agile coach was extremely charismatic guy, actually. He could say, hey guys, jump over the window, and everyone would say, yay! So charisma plus 10, right? So what he said, okay guys, fine, there's a wall, I don't care, you'll figure it out, how to solve it. Bring the pain forward. Just run and you'll figure out how to improve the delivery. And they run. It's like every day, the same message. Well, great message. However, the system started to crack in the middle. Basically, instead of trying to find a way how to communicate, under the pressure, they stop communicating. They start to isolate from each other to avoid this communication penalty. So, first of all, they stopped doing code reviews, daily stand-ups, everything, all the engineering practices that they used to use before. So, boom. And the code was growing, like architecture was growing, some knowledge, like islands started to appear that no one that let's say Latvian team can't understand, and vice versa. So, kind of problem. And at the end, continuous delivery ended up continuous blaming, actually. These guys pushed the code, it's crap, now we have to roll back. Oh no, I don't understand this piece of code. Who wrote this code? Who wrote this code? Oh my God, that's insane. You never write code this way. Fuck this. Americans, they don't get software development at all. And Americans say, Latvian guys, they blaming us all the time. They don't care, la la la. So, bam, problem, right? Problem. And here's the Conway's law shortened. Your team structure will override any architecture you have, right? So that's what happened. Teams start to override the architecture, like a run over. So, like a checkmate, right? That's the rule. That's the rule, really. So here's like a software architecture primer for dummies. If you have this wall between teams, you can try doing this, like working on a single code base. You can, it's possible. It's quite hard and challenging, right? So you better try to remove the wall. Or maybe you can try splitting the system, right? And what some companies still do, this. UI team, middleware team, database team, yay, woohoo! Can you really bring the value by changing solely middleware or changing the UI? You probably can't nowadays, right? Doesn't really work well, but it looks very smart on the paper, right? They can run in parallel, right? So this is even worse. So you better stick with this one, right? Don't get things worse. And obviously, sort of a reasonable solution would be splitting your software in some autonomous parts which can be owned by teams, like to reduce the number of interactions they have. And it's not actually about microservices. It's about making sure that teams are autonomous and maybe they have their own product owners, even budget, I don't know, planning. So they don't really hit like each other's asses all the time, right? So they're independent. So what can we learn from this? First of all, continuous delivery may require organization to change. And what's important, continuously to change. Because you can't make your architecture right from the first shot, right? It evolves. Your architecture, your software evolves, which means that your organization should evolve at the same pace. It should be sort of changeable as your code, right? You should be able to refactor your organization to fit your architecture, and vice versa, because usually refactor architecture to fit your org, but for some reason changing organization is usually much more harder. But that's important. That's very important. You have to adapt to change, right? I would say that some teams have very high pain tolerance. They suffer, they boil in fire, like they boil, and then they die eventually, right? Without even solving the problem. And usually the pain that you should bring forward, right? You should really bring the pain forward. It actually leads to painkillers instead of solving actual problems, right? People can just start isolating, right? And even agile coach might not even see the problem, right? Because I don't know why. Because he's agile coach, right? So, and kind of respect Newton's laws of software development. There are plenty of them on the market, like this, for example. How does a project get to be a year late? 1 day at a time. Obvious, right? This is from Mythical Man Month. So there are plenty of rules explained in this fantastic old classical book, Mythical Man Month. Who have read this, by the way? Fantastic. Only 15%. This is a classical book. Everyone should read that. And if you are actually pursuing continuous delivery in a large organization, you have to learn how to organize your software development given constraints that you have. And there's an awesome book from James Copley on Organizational Patterns of Agile Software Development. Okay? Fantastic. Let's move ahead. Misunderstanding of fundamental principles. We read blogs and we get information here and there, and it's quite scattered, right? And usually we read the practices that we have to implement, but we don't understand principles behind. That's quite common. That's quite common. And here's a list of things that I actually see companies are doing without understanding the background. So companies have deployment pipelines, but the pipeline is inconsistent. So you have tested the version 1, and you deploy version, I don't know, and you can deploy version 1.2 untested. So I would rather prefer having consistent deployments without deployment pipeline, right? I saw companies doing consistent deployment without pipelines. So just a solution, it's just a sort of tool, right? Or this one. Companies are testing data migrations, and they have this faulty sense of confidence because they test their data migrations on an either SQLite with 10 rows, right? Yay! So, and then like they go to production, transactions start to fail, right? Because alter table like blocks the whole table, right? But they have tested the migration, right? They're doing it, right? Or this one, we have to automate everything. Sort of, right? That sometimes is expensive, right? So why do we automate everything? To save time and maybe get some sort of confidence and avoid regression. And what if risk of failure, and what if accepting risk of failure is actually cheaper than automating everything? Have you ever thought about it? Maybe your automation is even more expensive than accepting some failure. And today, again, mean time to recover and mean time to detect was mentioned. So from the other side, you can have this confidence by reducing mean time to recovery and mean time to detect instead of covering everything by tests, right? Again, so it's about risk. It's about finding the balance. What can fail? What can go wrong? And this is my favorite. If something is difficult or painful, do it more often. You have a brick. And you hit your head against the brick. Boom, 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 boom. There's the blood already. Boom, 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 boom. It hurts, right? It hurts. And it's painful. It's painful. So according to this definition, should I do it more often? Sort of not, right? So what if we do something completely wrong? So what if we do completely wrong thing? Like there's something that we don't know, right? Right? Or what if we're doing the thing wrong? Again. So this rule is kind of dangerous, and I constantly see teams like doing something without even stopping and looking like on themselves from the outside. Dangerous. And one more thing. By the way, according to my personal statistics, people who are like helping companies to implement continuous delivery, they have never even read this fantastic book. That's a classic. Who have read this book? 10%! Yay! Fantastic. So you have to read it because basically people are doing obvious mistakes, and their knowledge is quite fragmented. I know this, I know that, but puzzle for some reason didn't really combine together in their head, and they do some weird thing. And you can actually invite me for a coffee, write me a message or tweet me. We can have some conversation about continuous delivery as well. Yay! Optimizing the wrong thing. Number 5. We have to move faster, produce more work, right? Yay! So we tend to push our work to someone, right? Usually, let's say you have developers and people in the team who are doing testing. Developers are doing testing as well, but there are, QA engineers as well. And usually there are less QA engineers in the team than developers, right? That's common, right? You never have more, I think so. And developers, they produce a lot of code. Yay, move faster, move faster, move faster, more work, more work. Fantastic. And doesn't really make sense to produce more work than your QA engineers can handle, because all we know what happens with people who are overutilized, right? They do weird things. They're doing weird things, and if you visualize what happens in such a teams, you'll end up with something like this, right? There's sort of bottleneck, right? More work, more. Hey guys, catch it. It doesn't really mean that there's a wall between them. It shouldn't really mean that they're throwing the work over the wall. It doesn't really mean that. They're just a bottleneck, right? Fantastic. So, and nothing is actually done, right? Because there's a bottleneck. So, obviously we can try pooling the work instead. Sort of implement more Kanban-ish style of work, right? And you can start like with extreme value, like setting the work in progress limit 1. We can't take more work, guys. Only 1 item at a time. And it will make it will be sort of bottleneck, but the whole work in progress will stop here, right? You can't really push more work because there is a limit, obviously, right? Fantastic. So kind of good, but still nothing is done, right? And then we do this. We put a limit here as well. So you try to push this large batch of work outside of your value stream. And first of all, again, it changes the dynamic of a game. So in order to make something done, everyone is interested in completing the existing work instead of picking new, right? It changed the way we work, we organize. So you can't take new work from the list anymore. You are forced to finish existing. Perfect. It will reduce actually batching again, which is quite good for continuous delivery. It minimizes risk, okay? There's also Little's Law. Who have heard about Little's Law? Old Little's Law. Fantastic. So what does it mean? Little's Law says that there's a linear relationship between lead time and work in progress. So what does it mean? That it's kind of quite unnatural to basically, the more work you have in progress, the faster you get your things to production. Counterintuitive, right? We usually think that the more we take in progress, the faster we sort of move, right? Because we took a lot of work. That's the opposite. The opposite is true. And by the way, there are empirical studies, obviously, that say that increased lead time causes lower quality because you kind of wait more to get things to production. And here's the formula to wake you up. So your team has 32 cards in progress, like a whip. And your throughput is 2 cards a day. What's your average cycle time or lead time? Doesn't matter in this case. How fast on average can you move to production? Think, mi friendo. Come on! Small little formula. Which is not always true, but most of the time. 16! Yay! I don't have anything to give you. Here's I don't know, whatever. so 16, right? Fantastic. So imagine your goal is to have a cycle time 1 item a day. How much work in progress should you pursue? How many items in progress should you have in order to have a 1 deployment per day, let's say? 2, perfect. So you reduce, actually. You don't accept more, you reduce. Fantastic rule, right? It works. It works. And here's the message. Basically, you have to optimize the whole system because obviously, in every system, stable, non-stable system, doesn't really matter actually. There's only one constraint that determines the whole system capacity, right? If your QA team, QA people can't handle more, or there's a bottleneck, you can't move faster than the bottleneck, right? That's it. You have to make sure that you're kind of self-organized to solve this bottleneck and move things forward faster, right? Quite obvious, but for some reasons it's not. 1 completed feature beats 10 in progress. Do you understand this? It doesn't really matter how much things you have in the progress, in this system. I would prefer at least something done. 1 item, done, that makes money, right? I'm an entrepreneur. 1 thing that makes money, and I don't care about this 10 in progress. It's almost done. It's not making money, right? It's not on production. And so sort of we are running out of time, I think so. Let's move on. Let's move on. Kanban book. If you want to learn about this, optimizing the value stream, visualizing the process, putting the constraints, the best book written in a human language, not for robots, right? Perfect. Delivering the wrong thing. What we forget about, that continuous delivery is not about delivering faster or something. It's about delivering valuable software in short cycles. Valuable. It's about value. It's not about features. It's about value. Value, okay? And what I usually see is this. So, pieces of shit that no one needs and no one cares about, they move through the deployment pipeline reliably, well-tested, right? It never fails. This piece of shit, it never fails. It goes to production, it's tested, people spend time on them. And then this piece of shit smashes production, like, right? Fantastic. So, wow, that's what we do as a company, right? Fantastic. Does it really make sense? Does it really make sense to deliver something that doesn't really make money, right? You can accelerate delivery of like a waste. You're just wasting your money. Your money, maybe your company's money. It doesn't make sense. So actually, before doing continuous delivery, sort of, you have to understand what value really means for you, for your team, for your stakeholders, for your customers, whatever. That's very important, because why are we accelerating then, right? And we have to understand how to mine the value, how to understand what matters for the customer, and how to bring more value to customers. So sort of few rules. Genshi Genbutsu, have you heard about this one? It's like from lean stuff, like go and see yourself. Go and see what your customer is doing actually. Go and see what problems they have, right? Easy peasy. Working closely with a customer service team, my favorite. Or maybe work as a customer service guy for some time. Maybe you're producing crap, right? Who knows? Just build it. Don't wait for someone to ask you to build something. Just go and build it. Be the initiator. Don't wait for ideas to fall on your head from the cloud and from your customer. Just build something, show it. Maybe that's the value, right? And become a customer. I still see people, great developers, brilliant developers, building fantastic customer-centric software, and for some reasons they are not using this software. So basically, developers are not using software that they are building. That's kind of weird, right? So, one more important message. You have to minimize output and maximize outcome, because you can produce a lot of work, millions of features to production, but at the end it might mean zero value. And even worse, negative value. Negative, right? So it doesn't really matter how much things you build, right? So like stop thinking in terms of these features and think in terms of value or impact you make, right? Fantastic. Technical obsessions, we're wrapping up. Yes, 3 minutes, exactly, I'll be fast. Technical obsession. Famous product company, Australia, and there are not many product companies in Australia, right? You can now start guessing. So, challenge, implement auto-deployment with auto-scaling. Decent challenge, reasonable. And they had the interesting stack, AWS Capistrano. But it's too simple and boring, right? Everyone is now on AWS Capistrano, no one cares about, right? So too boring. It sure would be fun to use Docker, right? It's missing there, just missing. Because everyone is using Docker. Everyone in the world, right? So if you're not using Docker nowadays, probably you're damned, right? And it opens new opportunities. Okay, what they do? They took CoreOS, because you want to take operating system that is container native, right? Fantastic. They installed Apache Mesos on top, because you want to program to your data center the same way as you program to your laptop, right? Exactly. But in Mesos, you can't really run long-living processes. They have installed Marathon on top. Fantastic. So 1 month later, Hydra was born. So, they have created a monster. So what is Hydra? Hydra is a water monster with reptilian traits. It possesses many heads, many problems, right? More problems than the painters could paint. And for each problem solved, like new problems bubble up. Exactly what we do in software development, right? We build Hydras, right? And they build Hydra. So, and since they have invested a month in this Hydra, They spent about 3 more months fighting with this monster. Maybe we can move forward, maybe we don't have to roll back. Maybe we can still solve these problems with Hydra, right? And they decided to capitulate. Fuck this Hydra, let's move back. So, my friends, 1 month to implement Hydra, 3 months for a fight, and 1 month to roll back, 5 months in overall to solve 2-week problem. Ooh, major waste, right? Quite expensive. Sorry guys, that's happened. So, and I have a rule for you. This is a formula. Can you give me anything that is trendy nowadays? Anything, anything. Microservices. Microservices are like teenage sex. Everyone is talking about them, but few have actually done it. Works? It's like a theory of everything. What? Something else? What? Docker, right? Docker is like teenage sex. Everyone is talking about Docker, but few have actually done it. It's like a theory of everything. I don't know. It just works, right? And by the way, if everyone is doing that, it doesn't mean that you have to, right? Maybe you're not Netflix, right? Or I'd say. So the law of flaky abstraction hurts, right? It might look very fancy, but the problem is that at some point you'll have to understand these abstractions all the way down, right? It hurts. There's even definition from Milford, complexity tax, that you pay for features that you don't use. Jira, for example. Your favorite, right? Fine. Let's move on. The last one. Giving up too early. I don't keep up with testing. Of course, your tests are slow, or you're doing it manually, right? Working in trunk is stupid and dangerous idea. Of course, because maybe you can't trust your test and pipeline. Deployment is so annoying. Of course, if you carry your flash drive to the team, right, to deploy. Of course. You really want me to talk to security officer? You really want me to talk to security officer? Of course I do. Security officer. And it does the work for us. We're so special. No one ever solved that problem before, right? We're so special. Yay. So continuous delivery causes so many problems, right? Right or no? No, because it actually reveals so many problems in your delivery pipeline, right? And there will be always obstacles. This doesn't work for us. So we're so special. A security officer wearing a suit, right? So, and the worst thing that might ever happen to you is you're just stopping in the face of these constraints. That sucks, right? And all companies have opportunities to change. Large one, big one, it doesn't really matter. So if you need some inspiration, right? Lean Enterprise will show how large companies do continuous delivery at scale. And it works for them, probably they're bigger than your company is. And you can learn how to change the world. In fact, you don't have to change the world, right? You just have to change your small company, maybe your habits, and the way you work. And that's it. Thank you.